I'm Nadav. I'm one of the 3 co-founders of Cloudinary. I'm a software engineer in my original training. I should show this. In the past 20 years or so, I've been working at various software development roles, managing software development teams, and building technology products for startup companies. It's great to be here in Munich, my first time here. I can't believe that the organizers of the conferences picked a day without a football game of Bayern, but maybe next time. I want to thank Stylight, Sebastian of Stylight, for inviting me here. What I want to talk about today is building and scaling a B2D service. Like you have B2C, business to consumer, or B2B, business to business, B2D, business to developers. We as developers build a service for developers, and this is the unique experience I wanted to talk about today, share some details behind the scenes, talk about some insights we and I have from this journey we had, and I hope you find it interesting. So back 3.5 years ago, at the end of 2011, me and my colleagues were working on building plenty of startup companies, web applications, web services, mobile applications, and they all had long product requirements of the specific product, but also had a short requirement line for handling user uploads, for cropping those images, those photos, delivering them fast to the users. And this small line of requirements appeared to be very time-consuming. It appeared to be something that we could never reach it, make it as good as we wanted this to be, because it wasn't the core part of the product. It didn't get high enough priority. So we wanted to eliminate all the R&D work involved in this, to let developers focus on the core products and let everything related to image management, the photo management, be completely solved for them. It involves image uploads, photos uploads to the cloud, administrations of the images, storing them somewhere on the internet, manipulating them, resize, crop, thumbnails, optimizing these images, and deliver them as fast as possible to users all over the world. So this was our initial vision, and we thought of first building a cloud-based API for supporting image uploads from mobile devices, desktop, laptops, and other kinds of computers, and to also have a URL-based API for on-the-fly image manipulations. So if, for example, this image is uploaded to the cloud, a URL, like the following one, can be embedded directly in website and perform image manipulations on the fly. As you can see in this example, some certain dimensions are specified, and in this specific example, face detection-based thumbnail is created for the original images while this URL is being accessed by users. So web developers can create from this original image any size, any cropping, circular effect, watermarks, changing colors, and plenty of others image manipulation effects. So this was our initial vision. We wanted to help developers, let them focus on the core product and save them time. But also, we thought that if it also makes money and we manage to build a nice business, that will be great, of course, as well. But as entrepreneurs, as technology people, we had some bigger dreams. We hope to one day become the leading image management backend of the web, leading media asset management backend of the web. We looked at Facebook numbers, for example, back then, that ended about 100 million new images every day. So we thought that a nice milestone in this path of becoming the image backend of the leading image backend of the web would be to reach something like these numbers, to handle dozens of millions of new images every day, which probably requires thousands of CPUs for processing this, and to build a nice customer base with at least 50,000 of customers and thousands of paying customers. And for building that, you probably need at least 10 great developers and tens of employees of support, marketing, sales, and other parts, probably in multiple offices. And it's quite obvious to see that for building that, you probably need, for building such a business, building such a service, you probably need significant amount of money. We estimated at about $10 million of initial funding. But what I wanted to talk about today is building and scaling a B2D service the bootstrap way, with zero initial funding, and which is the Cloudinary story. We decided to take this approach, not to raise any funds, and to grow the team, grow the product, grow the architectures while running, be very customer-focused, and again, to do everything gradually while running. So we started to implement the service, built a nice cloud-based service for image management, and created our first deployment architecture. in the beginning of 2012, which was quite simple. A single virtual server, a quite cheap one, using AWS, Amazon Web Services, EC2, Elastic Cloud, Compute Cloud, and working in this bootstrap path, it was critical not to re-implement the wheel, to use as many existing solutions as possible, cloud-based solutions, keep things simple and not play with too advanced technologies unless it's fun, of course. So to dive deeper into this architecture of the single server, it included a Ruby on Rails web application handling the business logic of the image management pipeline, and also image processing modules, either our proprietary code or various open source solutions we use. The data records and some indexing was stored on MySQL database on these servers, and the delivery was using the Nginx web server with a passenger module managing the Ruby on Rails container. The original uploaded photos and also the derived one, the generated one, those thumbnails were stored on the AWS storage service, simple storage service, and the delivery to the users, to the end users, was using the CDN, the content delivery network of Amazon CloudFront. So if we go back to the URL I mentioned with this on-the-fly image manipulation, this URL is delivered to users of our customers via the thousands of global servers of the CDN of Amazon. And if it's not already cached there, our application is reached, the Nginx fast web servers is accessing directly the S3 storage with our proprietary module for doing that fast. And if the pre-generated image is not already available, only then the applicative layer of Ruby on Rails is accessed for performing all the business logic involved in image management pipeline, processing the image, generating thumbnails, storing them on the storage, storing indexing records in MySQL database, and delivering the images all the way back to the users with advanced caching for the next request. And this simple architecture works nice for building quickly and having nice initial internal and some external customers for having a nice cloud-based solution. And again, going this bootstrap way, not having a lot of initial budget, it was important to keep the service simple. And for example, our service involves a lot of on-the-fly image processing, which means that if our customers have tons of users coming with requests for delivering those images, this might result with tons of image delivery and image processing requests. So it was, in our case, important to have multiple cache layers to protect our application server. The most important one was the CDN, the CloudFront CDN, that acts as caching not only for the generated images, but also for those API calls. And the generated images, not only the original ones, we also store them persistently on the S3 storage and deliver them directly via the fast Nginx web server instead of accessing the application layer, which allows us to keep the service simple, not have significant number of servers. And another important part of this is that all those cache layers and storing the generated images means that the image performance, the performance of the image processing is relevant only for the first user access. So there's no real reason, at least at this point, to optimize the performance of the image processing or to have stronger servers or to try out to integrate some GPU-based acceleration of the image processing. So we had a nice vision for a cloud-based solution. We implemented our first service, and then we had a cloud-based API for image management and upload transformation and so on. But we wanted to get some customers, some traffic, some traction. So what's next? How to do that? One of the first things we realized is that having a public API, a cloud-based API, as good as it can be, was not enough. Developers look for SDKs in their specific frameworks. They look for writing code the way they used to work and to do as minimal code changes to the service while integrating. So the first thing we did is created a RubyGem, a library for the Ruby on Rails web developers. Ruby on Rails back then was the most popular web development frameworks, at least for startup companies, and it's still very popular today. So instead of creating those quite complex image delivery manipulation URLs, developers are used, at least Rails developers used to work while building their HTML templates to build this image tag view helper method that accepts the name of an image and dimensions of a pre-created image. So what we included in our RubyGem is a Cloudinary image tag, a CL image tag. Exactly the same syntax as the image tag, the original image tag, but this time also supporting additional options. The developer works exactly the way they used to work while building their HTML pages, but behind the scenes, all image processing takes place in the cloud, no need to install any image processing solutions, and the image tags are generated with those remote URLs. And then we can also push this further and add additional, more complex features, like in this case, setting the crop mode to thumb, gravity to face for creating this thumbnail, face detection with thumbnail of the same original image, while, again, everything is done in the cloud, developers work exactly the way they used to work in the code. Another example, also for the Ruby on Rails community, is there's for Ruby a library, popular one called Khare, which manages the pipeline of attachments and image uploads. This code defines an image attribute for users to upload that should be converted to the JPEG format while uploading, and 2 different thumbnails should be created for displaying in web pages. Using this code without Cloudinary uses local storage, uploading to a local server, requires installing unknowing image processing solutions like RMagic, ImageMagick, GraphicsMagick, other kinds of magic, and the delivery is via regular URLs, regular server URLs. When using Cloudinary, we created a Khare plugin. So all they had to do is include this single line of code, adding this plugin. All other code parts, either the image upload form or the delivery, the thumbnail generation of the developers of those existing applications remained exactly the same. So the concept of doing minimal code changes was very strong here. And behind the scenes, the images were uploaded automatically to the cloud, storing in the cloud. All image processing took place in the cloud, no need to install any software at all. And the delivery was using optimized CDN delivery with advanced caching. This specific concept of those minimal changes, one liner of code for developers, and tutorials we had for it, was actually one of the main first engines we had for traffic, for customers, for revenues, because it was so easy to integrate, and is still one of our most successful features today. I mentioned the Ruby gem, but of course there are so many frameworks. You need to support all of them. With the tighter integration you have, the better chances you have the developers to successfully integrate. So not only Rails, but also PHP, Node.js, Django, jQuery, Angular, Java, .NET, Scala, iOS, Android. We created SDKs for all of them. And there also you need to pay attention to some sub-frameworks for having successful integration. For example, for PHP, you have Cake PHP, Cloudinary, Symfony, and plenty other sub-frameworks that you should probably want to integrate with for allowing developers to successfully integrate. And there are also some cloud hosting solutions like Heroku, or the applicative one of parts of Facebook, or e-commerce solution like Magento, WordPress solution of CMS solution, other cloud hosting solutions like Engineer, or the German one of Cloud Control. And you should integrate with all of them for allowing the developers to easily integrate. And also pay attention to some nuances. For example, we first had our jQuery library, and then we created an Angular library. Both were JavaScript-based. We built the Angular library using the jQuery plugin, but then the Angular community came and said, no, this should be jQuery free. It should be pure JavaScript. It should not depend on jQuery. So this is something we had to change. And development frameworks are like religions. They have their own conventions and rules, and you need to live by them. For example, the Ruby gem I mentioned was downloaded more than 300,000 times by users, by developers, and we have more than 500 paying customers using this gem, and they seem to be quite happy with this. But still we get feedback like this one, that thing is a dog's breakfast of long methods and needless complexity. And another example of the Node.js community, we included in our Node SDK this method for uploading images to the cloud, specifying a name of a local image file, a callback to be executed when the image upload is completed, and an optional map of manipulation instructions. It looked nice, quite nice to us. But then the Node.js community came and said, no, this is completely wrong. This should be the correct syntax. For a general developer, this might look exactly the same, but for the Angular community, the Node.js community, this was very important. Having the callback must come last, and it should first accept a parameter, which is an indicator whether the upload was successful or there was an error. So again, we need to understand all the conventions and build the frameworks, the SDKs for the specific frameworks, the way developers are used to work. And frameworks during those years, they come and go, the popularity change. And for example, this chart shows the popularity, the percentage of Cloudinary's customers of those 2 frameworks I mentioned, Rails and Node, during those 2 years. Ruby on Rails frameworks were very popular back then, and it still is is still very popular, but the Node.js community, the Node.js users of using our SDKs are getting more and more popular. This might be the result of the content we create, the specific tutorials, but it also reflects some global trends in the popularity of those frameworks, and we already need to support those most popular frameworks. And for example, the new rising star is AngularJS of Google, which all users suddenly start requesting that we support it. So we created an initial cloud-based API, and then those SDKs for all popular frameworks for allowing users to easily integrate, but obviously in order to let them successfully integrate with the service, successfully use the SDK, it was important to create documentation. So we created API documentation, but more importantly, we had to create framework-specific documentation. Developers looked for code samples in their specific language, not just seeing reference implementation in a different programming language and converting to theirs. They want to see instructions in the terms they use to work. So we created framework-specific documentation, tutorials with code sample, blog posts, recipes, and various other technical-oriented content, which allow developers to successfully integrate with the service. But this also had a nice side effect. This had great SEO impact. For a company like ours that went in this bootstrap path of not having significant marketing budget, at least in the first days, having those technical content had great marketing value. Developers looked for solutions for their needs. They found out about, reached our service, our documentation, our technical content via Google searches, learned about the service, signed up to the service, became paying customers. And this was, and it still is, the main driver for customers' revenues. Those technical documents, technical blog posts we have is the main successful marketing channel we have. So we work quite hard on building all this documentation for our frameworks, and customers seem to appreciate it. But exactly at the same time, other developers felt completely different. They said, it's a pity to see great tools obfuscated by poor documentation. I love the features, but can you guys please have better documentation? Or even, I don't think I've ever worked with docs so poor. So I guess we still have a lot of work to do in improving those content. And in order to complete the picture and allow developers to successfully integrate with the service, it was very important to have great support team. Just in the last month, we got about 1,000 support tickets, asking various features, general requests, general questions. Many of them come from developers, and are answered by our support, our customer success team of developers as well. And this developer-to-developer conversation appeared to be very successful. The developers, our customers, share their code, ask for assistance, ask for ideas for how to implement certain complex features based on our image management building blocks. And our developers help them fix their code, implement their code, and have a successful integration, but also become happy and tell their friends about this. And this is also part of our bootstrap way, without significant marketing budget at first. This word-of-mouth effect was very powerful in making the service being used by more and more developers. So we had a nice API, created SDKs for all popular frameworks, created a documentation, framework-specific one, great support team, and started to have nice numbers of customers and daily new images. And working this bootstrap way, we kept updating the architecture while running, adding more computation power, changing the architecture. And this is the updated architecture in the beginning of 2013. Instead of a single server, obviously, we already had there multiple servers, multiple instances, stronger ones, using the auto-scaling group of Amazon to add more servers according to the load. We separated the UI user interface cluster and the API cluster. We kept using the Ruby on Rails application while adding many new features to the business logic image processing, and also added background processing for performing some image processing in the background. We kept using the Nginx fast web server, storing the images and the generated ones on the S3 storage of Amazon. We added ELB, Elastic Load Balancer of Amazon, for balancing the load between all those servers. And we switched from the CDN of CloudFront to the CDN of Akamai. A few more words about this in a minute. We also switched from a local MySQL installation to the hosted, managed database infrastructure solution of AWS in multiple availability zones for better performance, management, and scalability. And we also started integrating with SQS, the queuing service of Amazon, for being the infrastructure of the background processing we added to the service. So this was the updated architecture, again, kept enhancing and advancing while running, and it worked quite well in handling the nice load we started to have with customers such as Stylight. The switch to Akamai that I mentioned, first of all, CloudFront was great. It was very easy to set up. You don't need to pre-purchase significant bandwidth. You just pay from the first byte. But still, we switched to Akamai, first of all, because customer demanded that we do it. Akamai had better premium brand, and they wanted the images to be delivered using Akamai. Another thing that, at least back then, Akamai had wider global presence than CloudFront. For example, in India, where CloudFront don't have ad servers, or in Israel, a local country where we have some nice customers. Another technical advantage of Akamai was better in caching validation, which is quite important when you talk about small images, public images that might need to be updated or completely removed from the web. And surprisingly, in our case, Akamai, although it is a premium service, was cheaper. This is mainly as a result of the fact that AWS, Amazon, charges not only by bandwidth, but also by the number of requests. And because we talked about images, small thumbnails, the average image size back then was about 15 kilobytes, which results with the fact that there are tons of requests, and therefore the cost of requests becomes bigger than the cost of bandwidth, while the bandwidth cost is usually the more negotiable part of the price. So we switched to Akamai, and we're still using Akamai, and it worked great for us. An interesting challenge of building such a service is the auto-scaling challenge. You always have to have enough computation power to handle all the load, the changes in load, traffic come and go, there are changes, spike, bursts. You need to handle growth, organic growth of customers and their traffic. You need to handle certain bursts of image requests and also handle a single customer burst. For example, when the customer is launching a new website, many of his users are coming to request new images. So it is important to do that while scaling up as quickly as possible, to add more servers as quickly as possible, to add those spikes, those changes in load, and to also correctly detect when to add more servers, whether it is CPU bound, the servers, the iCPU utilization, or IO bound. There are many concurrent requests for fetching remote images. And you should also make sure to have enough extra servers to handle all those smaller changes in load, but while having those extra changes, not waste too much money on those extra servers. So the way we did auto-scaling is, first of all, have enough extra servers and to reserve those instances for a year or more. When reserving instances of Amazon, you cut costs by at least 50%, and in our case, again, the bootstrap way, it was very important. Another part is that we add those instances in multiple availability zones of Amazon, so even if there are some networking issues in one of them, you still have enough computation power to handle the load on the system. And we optimize the AMI, the server images of Amazon, that are responsible for the boot time of the server, to have minimal setup on load. So those servers come up, boot up, start up as fast as possible, so we can scale up quickly. So we use the AWS auto-scaling group I mentioned with two different sensor thresholds, either CPU bound, when there's a significant image processing involved requiring a lot of CPU, or when there is a lot of I/O, when we have many passenger processes concurrently running, handling the fetching remote images while not necessarily consuming a lot of CPU. And it worked quite well, managed to without spending a lot of money, always have enough servers to handle the load, the changing load, and the growth of the service. And another important part of this is the need to handle single burst of a single customer. A single customer should never break the system, should never overwhelm the system with too many requests, too many heavy processing that affect other customers. The system should always work perfectly for our customers, and it's mainly relevant when our customers launch a new website using Cloudinary, and then tons of users come to request new image processing, new image delivery. So what we do in order to handle this is to use the Redis memory daemon, and we track the number of concurrent requests per customer, per server. So we can, if a single customer exceeds a certain limit, we can queue the requests of these specific customers while scaling up, while adding more servers, handling the additional load on the service. And so this specific customer in this huge burst, it's mainly relevant for big customers. For smaller ones, there's no problem. We queue the service for a few seconds and scale up the service. Another very important part of a service like ours from day one is the need for advanced monitoring. Cloudinary service is in the heart of our customers, on the production service of our customers. It's not just a side service or an add-on. If our service is down, their site is partly down, the service is partly down, the images might be broken, the users can't upload images. So it's quite obvious the system should always work perfectly. For example, two of our customers are Outburn and Tabula. They both have content recommendation widgets that are used by the largest and most popular news sites and other sites all over the world, which means, including many in Germany, which means that if there's a certain issue on our side, on Cloudinary, those images might become broken on the site, harming the user experience of those so popular websites, and also might result with losing money. So therefore, monitoring of a system like Cloudinary was critical. So although we went in this bootstrap way, we spent time and later on money on building advanced monitoring solution. We leveraged various third-party solutions and built some in-house monitoring services. We used AWS CloudFront for monitoring the server infrastructure and the networking. We used New Relic for monitoring the applicative layer, the databases, and the application servers. We used Pingdom for checking the responsiveness of the service from all over the world. We created a monitoring analysis service using Logstash, Elasticsearch, and Kibana, analyzing all delivery logs, checking for issues, providing us nice dashboards, finding customer trends, global trends, and again, going with this target of finding those issues as soon as possible to preventing any system downtime. And since we started the service, knock wood, I guess, we never went below 99.99 or some other number of nines uptime. I guess it's important for those that count the nines. We also had various other log analysis and applicative monitoring we built for checking any system issues beforehand and making sure that, again, there's no issues. And another important part is, at the beginning days, while we had a small team, it was important to always be awake when such issues are encountered. So we created a nice service using Twilio and Microsoft Azure Cloud, and whenever an issue was detected externally, we triggered phone calls to all relevant members of the team, making sure to wake up at night because regular messages and notifications will not work, and it worked nice for us as well. A service like Cloudinary that handles images, photos, pictures, has so many possible cases and therefore so many possible error cases, potential errors we might encounter. There are many image formats, those specific image formats as various color profiles. The requests of our users come from various different frameworks in various different operating systems, and those upload requests and the delivery to the users come from and to various devices, mobile, desktops, and other computers. There are many versions of all of image formats, devices, and operating systems, and also many different resolutions of those devices. So there were so many possible errors that we need to find and prevent. So we used Airbit for analyzing all logs of the system and the applicative layer and get notifications about any possible error in the service, also ones that our customer didn't even realize they have. And more importantly, for each such case, we created thousands of automatic tests, which allowed us to keep being very customer-focused and to update the service on a weekly or even a daily basis with new features without breaking anything, while making sure all those thousands of cases are still handled and handled well. So we kept growing, having more customers, more images, more daily new images, and the numbers were becoming very impressive, the number of concurrent API requests, the size of the companies, their brands, and we kept updating the architecture while running. It requires, of course, to have a great team for that. And this is the updated architecture back at the end of 2014. We switched from certain instances to much stronger ones. This is why it is changed to red. And those instances are using the SSD flash drive, which gives much faster performance. And we also have so many more servers and kept using those scaling group. We still had those Ruby on Rails application, the Redis daemon I mentioned, and we added a Scala daemon for performing some image processing actions in Java and in Scala, Java-based and Scala. Kept using the Nginx module, the S3 storage of Amazon, multiple load balancers in multiple availability zones for, again, better availability and performance. Kept using the CDN of Akamai, the SQL service of Amazon. We switched from the RDS hosted solution of database to multiple MySQL clusters, sharded ones, each set of customers in a different MySQL cluster. Those clusters in multiple availability zone, multiple service, again providing higher performance, higher availability. We started a transition to the Cassandra NoSQL database for better, our system is very write-oriented, so having better write throughput, and also, again, more availability and scalability capabilities. And we integrated Elasticsearch, the indexing cluster of Elasticsearch for having supporting advanced image searching options. We included the Logstash cluster I mentioned for all those log analysis and dashboard creation, and integrating with various third-party add-ons of image processing that were fully integrated in the service, and plenty of other smaller modules that I didn't include in this diagram. And it seems to be worked very well. Again, we still add those cache layers, the CDN layer, but at this point, the service was accessed daily by so many requests, image processing, everyone's images were getting bigger, customers were getting bigger, but it worked very well. I mentioned AWS quite a lot in the last 30 minutes or so. In our case, AWS was very cost effective. It's not expensive as its reputation is sometimes is. The fact that you can also reserve those instances, if you know beforehand how many instances you need, cuts cost by at least 50%, as I said, which is very significant, and then it becomes very cost effective. They have powerful services, either the database one, the applicative one, managing your infrastructure, and some other more applicative layers like sending emails and so on. And the flexibility it gives is amazing. The fact that we could switch, we had tens of servers running on regular hardware, and we switched to much faster, more CPUs, SSD-based service in a single day without any additional costs is something that you can only dreamed of in the past with regular data centers. And it was very, especially powerful when you talk about quick start boosting, so you don't need to build things by yourself. You can use those existing solutions instead of trying to figure out how to build, especially if you want to talk about scale, if you want to talk about availability. So this is the list of most of AWS services, and the yellow ones are ones that we are using or used in the past. Now that we had significant number of customers and daily images and processing, it was about time to do some performance analysis, either to reduce the time involved in the image processing, to have faster API responses to our customers, and also to cut our CPU costs. Now that we have so many servers, it became very costly, so it was important to reduce this cost. So we built a nice system tracking the sample transformation, CPU usage, image transformation, store the data in a Cassandra NoSQL database, and display the results in nice charts using the D3 library to analyze the performance usage. We had some guesses internally before starting the process. We thought that this might be the main CPU consumption would be because of multiple thumbnails created for each image, or maybe the image rotation effect, or maybe our most popular feature, the face detection-based cropping. But we were quite surprised to see that the first thing we found out responsible for the major part of CPU was Ruby execution of some external image processing commands. We use, in addition to our code, we use various image processing command lines, and they appear to be very CPU intensive. For example, this is the original code using the open-free method for executing the external processes and getting their input and output. This is the updated code we use using POSIX-spawn, exactly the same functionality of executing the external commands, but the results were quite amazing. This chart shows the overall CPU utilization of the system, which dropped by 30%, which also means 30% drop in our server costs. And users also felt this change, because this resulted with 25% drop in the average response time, the average API time of the image processing in the system. So again, this small code change, which seems like something not very relevant, was responsible for a very big boost. So to slow down a little bit, as I mentioned, we went in this bootstrap path of growing the service and team and everything gradually. And in our case, it works extremely well. We had a small team of developers at first, and I think it's critical. I believe you know also from your experience that a single great developer probably worth more than multiple just good developers. And the architecture was progressing gradually. Again, another challenge, changing it all the time with new features, those new features ending the bigger scale, bigger number of requests, adding features, being very customer focused. Again, it was also part of our marketing efforts, making those customers happy, adding features on a weekly or even a daily basis, and of course, having a great service, great support for making the customers use the service successfully. And this was also part of the grassroots marketing involved and the technical content created, which were our main engines for traffic. Now we have much bigger budget and marketing, but still this is very successful, the technical content oriented. So I want to share some of Cloudinary's numbers today. You might recognize some of them for the slide at the beginning of the first milestone of becoming the leading image backend. So we currently have about 55,000 developers that sign up to the service and about 2,000 paying customers from 65 different countries that range from small startups to 500 to Fortune 500 companies. By the way, Stylight started as a very small customers of Cloudinary, is now growing with us to become a much bigger customer. And we handle about 20 million new daily images every day that added to the service and deliver about 1.5 billion images every day. Well, it's important to understand that the bigger customers of Cloudinary have their own CDN layer in front of us. So the actual number of images being delivered every day to users all over the world is much higher than this one. And in order to handle this, we have about 1,000 CPUs for handling the API requests and the image processing involved. But again, this is just the first milestone. This is just the beginning. Not everybody are using Cloudinary. Not everybody heard about Cloudinary. I guess not all of you heard about Cloudinary yet. Now you do. So the challenges in scaling are becoming now much bigger. Bigger companies come, the amount of traffic, the size of the images, the feature they request, so the scale challenges are bigger. The architecture keep evolving for handling the bigger load, those new features. And while keep being very customer focused, we keep adding new features on a weekly and even a daily basis. And this is, again, a challenge we still face. So again, just the beginning, we have a lot of things to do. And just before I end, one more thing, which is video. When Cloudinary started, since day one, people that heard that we handle image, photo management, media management, they asked, okay, you have support for image, what about video? And we are quite happy that we decided not to support video back then. Back then, developers' sites use YouTube for hosting their videos and used some, didn't allow users to upload videos. But now the market is ready. Our customers came to us and said, please support video. They wanted the same capabilities we have for images, with upload, on-the-fly manipulation, fast delivery, to also be supported for video clips that the users can upload. Like any WhatsApp application, users can now upload images and videos exactly the same way. So we added support for video. And the same URL-based API is used for delivering those video clips directly to the users with advanced caching, optimizing for any web and mobile devices while on-the-fly transcoding, real-time processing, cropping, and various other effects. You can upload those original images, deliver them to any, again, optimized to any web and mobile device, crop them to any size you want, any graphic design you want to match, add watermarks, text overlays, again, in real time, on-the-fly transcoding in the cloud, and rotate and various other effects. This, of course, the handling of videos requires much longer processing times. Processing long videos, or even shorter ones, is much heavier than processing those images, as big as they are. And this required some significant architecture changes on our side, adding, for example, a cluster for video processing, another cluster for some distributed locking, and various other architecture changes that we are still working on, but I guess this is for next time we meet. So that's about it. I hope you found it interesting. Personally, I think that this journey we took of both the bootstrap way of not having significant budget and growing the service, the team, the company, the features while running, and as developers, building a service for developers like we did, we initially built the service for ourselves, was was fun. I can definitely recommend it. And again, it's just the beginning. We still want to be the image backend of the web, so there's a lot of work ahead of us. So, any questions? Yes. The team is now, should be approaching 30 people soon, and we are hiring, we should double in the next few months. Most of it are technology people, developers, and as I mentioned in one of the slides, we have very good people. A single developer can do a lot more, but it's also very challenging to find those people. Actually, our main challenge in Israel is to find great developers because Google and Facebook are taking all the great developers. What? Sorry, I didn't.
Imagine that for some reason, I don't know why.
He's bringing.
Okay, so imagine for some reason your cache layer is not working. What would happen?
First of all, if Akamai is down, the web is down. So, and same goes for Amazon. So this part. But again, I think that in the numbers we talk now, without having a CDN of tens of thousands of servers all over the world, it's hard to deliver those images from a service. So I guess we need to face this issue, but the scaling, the auto-scaling mechanism in concept, and we are still working to improve it, should be able to scale, in significant numbers to handle much bigger loads. But the number of delivery compared to the number of the actual image processing is there's so much difference between them. So you need to depend on a strong cache layer.
Yeah, and also, is there any way like having some higher prioritized customers who are delivered their images as the first one, and if there is a lack of resources?
We do have some part of the modules, like I mentioned, for the database applicative that we can do like sharding and split it according to priority of customers. And I guess that as we now that we have, for example, at the beginning of 2014, 70% of our revenues came from small customers. And at the end of the year, 70% come from big customers. So we're in a transition for those small startups to bigger companies. So I guess that it's something that probably should happen. But as engineers, as developers, we prefer to have everybody equal and shared system for all kinds of customers.
Okay, thank you.
Regarding video processing, do you do it on Ruby or?
Just as well for image, we are using, we have some for images Ruby code and tens of open source solutions integrated in service and our proprietary code and also some Java and Scala code. Same goes for video. We're using some open source tools and also some our proprietary code. For example, one of the features we have, you can take a video, resize it, add a text overlay of a certain style, and then add in multiple image overlays. These small actions involves, again, running tens of image processing and video processing combined together for making the developer life just one parameter for creating that.
How do you deal with the cache management and invalidation and also avoiding storing one object, one image on too many layers of cache?
The delivery of the image at the cached is done currently by the CloudFront CDN or by the Akamai CDN, which this is their job. They should keep those cache of images. And most images of customers, as you know, are public. So invalidation is something that is not very common, but still, in some cases, when they don't want to do some versioning techniques is needed. And Akamai has their own APIs for doing this invalidation, but CDNs don't like invalidations. You can't do it very often. And the cache on our side, we store those images because from our experience, about 20%, even if you have the best cache, about 20% of the requests will still reach the applicative layer for generating new images. And therefore, if you didn't store the generated images, you need to recreate them every time. So we store them, but the cost of this is just data records mainly on the S3 storage. So there's not much overage except for the storage cost.
You're using all these external services from AWS, Logstash and so on, which is great for production, but how does it work in development or testing? Do you stop or mock all these services, or how do you handle that?
That's a great question that we face, the engineering team face every day. Some of the things do work with the AWS services directly. For example, the queuing service of the S3, you can simply create another S3 bucket and use it from development, because otherwise you'll find those issues on production or staging systems. But we do have some mock systems for most of these solutions for running all those thousands of automatic tests without the need for accessing remote services. But the core part of the service can run, it works on my laptop now, all Ruby on Rails databases, MySQL, Cassandra, all other solutions, and we can mock, for example, this S3 storage with a local drive storage.
Thanks.
So,
did you experiment with, and if what have been your outcomes with the spot market instances of EC2?
Yes. It worked well. As a bootstrap company that was looking for ways to work efficiently, to find tricks, to find shortcuts for things, one of the first things we did for having more server, more computation power is to use the spot instances of Amazon. If you're not familiar with this, you can bid servers that are not currently used, and if the price depends on the demand, it can be 100 times cheaper than the regular servers, which allows you to have huge clusters with almost zero cost. We used this. We created some cool scripts to load those servers, remove them, move them between availability zones, handle those bid changes that the bad part of this is that they can take you those servers immediately. They don't promise you anything compared to the expensive ones. But then came the big Bitcoin farms, and everybody took those spot instances and it stopped working. So we switched to regular instances and reserved them for cutting the costs.
Okay, so you handle this content, but do you have any content filtering worldwide? For example, somebody uploads a copyrighted image or territory-based content filtering like the Gamma in YouTube?
Yes. Some of our customers are social networks or sites that allow users to share content, and then sometimes they're immediately shared with the audience, so it's important to moderate them. Various kinds. It can be adult content, it can be violence, it can be copyright violations, as you mentioned. We have multiple solutions for that in the service, either manual moderations. Some of our customers have their team working on a queue of images, and technically we make sure that those images have short-term caching, so you can quickly update them and delete them from the web if they're bad. And we also integrated with some third-party solutions. For example, Web Purify. They have API, automatic API for image moderation. Behind this, there are some poor people doing this content moderation, watching all those images for adult content. But for our developers, they just need to set another parameter while uploading. Moderation equals Web Purify or manual, and automatically the images are sent for a check, and if any issue is found, they're removed and notification is sent so they can upload the site. Either wait for approval before updating and showing the site, or remove it afterwards, like Facebook and other services do with the report button.
You showed that you are using Glacier. What for?
We used Glacier in the past. Cloudinary, like any production service, need to prepare for the end of the world, for any disaster. So we keep the images in disaster recovery, secondary data in other cloud providers, other locations, and which this data is not required for online actions. Therefore, Glacier was very cost-effective. So we use Glacier for that. But Currently, we're using it less because we still want this online behavior of S3, and there's some way to cut costs when using S3 as well with lower availability of the backups.
Sorry to interrupting. It's a pleasure to listen to you, but also we have to get the next speaker a chance and to give you the chance to switch rooms if you want to hear the other talk and give the people from the other track give the chance. So Nadav, thank you very much for the talk.
Thank you. Thank you.